we talk about our motion technology, we talk about a huge variety of possibilities. You might know this with all the different drives. We have already the AX1000, 8000, 5000. We have all the different motors and different scales, so the variety is large. And this is by reason, because your application requires so many different functions and features. Now, if you would to understand completely the variety, you need an expert, and I have an expert here, not by accident. We planned this. Good morning, Christian.
Good morning.
Now, if we want to get some light into the dark, of course, we can have somebody from our sales team, application team, or you for product management, and he explains all the functions and features. But we also have a software tool which can help the customer to easily configure his application. So what is this tool all about?
Yeah, we designed it to help our customers, mainly the mechanical guys, to find the right solution for their mechanical load case. So finding gearboxes, drives, and later on the cables and the motors and so on. And yeah, I can show you in a short way what it looked like. So this is our motion designer. On the left-hand side, you can see different load cases like this belt drive here, or there are several other ones. So the mechanical guy selects then his load case and has to set up all these mechanical data of diameters and lengths and so on, and also the load that has to be transported through the machine in a specific time. This is a very complex load case, like a crank gear, but all is supported in vertical horizontal way, and after that, we design how the machine should behave through the mechanics and define the motion profile for that. That could be a CSV file or our 7-segment profile.
Okay.
After that, we select the components. We get a torque curve for the gearboxes and the motors. And if everything is green, we found the optimized motor, we found the optimized gearbox, get a bill of material, and there we have only to select, is the shaft of the motor a smooth shaft or feather key in, or which encoder we want to use for, and if it is for safety, needs it a holding brake. At the end of this selection, we get a report of the individual axis, and the work is done.
So this must have been done all manual in the past? Well, we can use this tool for a while already. It's not a brand new tool.
I did it 20 years ago manually with calculation and formulas.
Now it's guided through like a configuration system. But Christian, I think you made it a little easy pass, because this is just one axis. And honestly, who needs only one axis? So I think this is too simple. So what is the next level?
For sure. You have to do that for several axes. Yeah. Today's machines have 20 axes, 100 axes. So you do that several times and start this process then again for everything of that. After that, we get a DC link overview. So all these axes are connected to one power supply. They share the energy. And we see in this overview what we did up to now. So we have the different axes, which motor is connected to that, which load case and mechanical data are connected to that. But the most important thing is then this overview, how much energy these components need. And it's not only that one motor starts at the same time like the other one. One is starting, the other one is decelerating and giving energy back. So the power supply is usually not that big like all the sum of the axis power. So with this, we see that and can select a braking resistor, or we can select the right power supply. We can find out if a regenerative module can do that job. And also here at the end, we get a complete bill of material of this complete machine that will be presented to our sales guy. And if he does a good job, he gets that job and we get the order.
That's what a manager loves, that there's a bill of material at the end and we can get the order, right? So perfectly done. Now I got the bill of material. That means I place the order. Hopefully everything is on stock, which is actually very valid these days. Parts are delivered. So what is the next step for the customer now?
Yeah, then we have to get that up and running.
Yeah.
So in the meanwhile, the design guy has to do the sketches and get also the E-plan macros out of our tool and so on. If that is all set up and the cabinet is already there, if we are lucky, power is on.
Good choice, power is on.
Yeah. We have our drive manager for that integrated also in TwinCAD. And there we see which power is connected. If it is single phase or 3-phase, we can select tolerances for different countries, which is sometimes necessary. Select if an external or internal braking resistor should be used. And because all of our components have electronic nameplates, we also see for specific motor, a specific speed torque curve, how the motor behaves then. We can see there what the setup is for the NC connection, if there's a specific gearing in between. But this is then the highlight of our drive manager. With one click, we get the axis running and we get it tuned. That's the main thing.
So auto-tuning is auto-integrated?
Auto-tuning is also integrated. One click on the start button and we see here a difference of 1 to 70, 60. So the axis is optimized for hard running. We have a scope integrated and can see how it behaved before, for the auto-tuning, and after that. And we can see that all these spikes that we had before are gone. So we have a very smooth behavior then of this axis. And that happens within 2 or 3 minutes.
Wow, so with the motion designer, I get the right bill of material. And now, as you're the drive manager, I basically get it up and running.
Yeah.
So what do you do in the future?
We do optimizing the software and hearing your customers, adding some new features.
I think this is great because a lot of people really sometimes get confused with the large possibilities we have, and such a tool is a great help for our customers. Thanks for the explanation, Christian.